All right, so today we're going to talk about regular parallelograms and the properties of those four parallelograms. So first thing here, we have opposite sides of a parallelogram are congruent. So we already know by definition they're parallel. They're also going to be congruent. On the yellow chart you have, if you go down to box 3, that will be box 3 for you. You can check that off to organize the different properties that these shapes have. All right, so here's an example here. Consecutive angles, right? So in a parallelogram, these angles are called consecutive angles, or also same side interior angles. And those angles are going to be consecutive, and the property of those is supplementary. So these two angles are going to add up to 180 degrees. K and M are going to add up to 180 degrees. M and O are going to add up to 180 degrees. So given this is a parallelogram, we know that consecutive angles are going to be congruent, or supplementaries, right? We take 180 and subtract what's given, and that would make angle K 145. 145 minus 180 will give us 35 for that angle. And we continue going all the way around the parallelogram. All right, the next theorem says opposite angles are going to be congruent. So if we look back at this example, we see opposite angles here are both 35. Opposite angles here are both 145. So from this property, we can now use this property saying that opposite angles are going to be congruent, and that's going to be box 17. So here's an algebraic problem where opposite angles are given and we know they're congruent. So one angle will equal to the other angle, and we end up finding y is equal to 11, and then when we plug it in, we get 70 degrees for that. So now if these are 70 degrees, we know these are consecutive angles, meaning they're supplementary. So this plus this has to add up to 180. So that's going to make that 110 degrees for those other angles. All right, the next one, diagonals. Diagonals of a parallelogram are going to bisect each other. So when they go through, one side of it will equal to the other. This side will equal to this side. Doesn't mean they're the same length, but they get cut in half, each split in half when they intersect. That's going to be box number 10 on the yellow chart. So here's an example that's a little bit more advanced than what we need to cover. But what we know is this is equal to this, and this side is equal to this side. We'll do a different example in a minute where it's a little bit easier for us to do. Here are some things that we're going to talk about now. If you're given a part, it determines what shape it is. Where the previous theorems we've had, it tells us the shape and what the part does. This is what we're going to do. We're going to take the part and it's going to tell us the shape. So here, if diagonals bisect each other, we know it's a parallelogram. If the opposite sides of a quadrilateral are congruent and parallel, we have a parallelogram. But in fact, we only need one pair to prove that true. All right, here's another example. And so for A, we see we're dealing with angles of a parallelogram. And these angles, there's two properties we know. Opposite angles are congruent and consecutive angles are supplementary. These are going to be consecutive angles. So if we add these up, they're going to add up to 180 degrees. And we get a value of A is equal to 70, which is this specific angle. Okay. Over here, we know opposite sides are going to be congruent, so we can set these up equal to each other and get a value of 2. In the directions, they only want the variable, not the actual side length. So these answers would be enough for us for this problem. All right, here's an example going back to the diagonals. So we know diagonals bisect each other, so this part equals to this part. This part equals to this part. So if we solve for x first, we'd set the two bisected parts equal to each other and then go ahead and solve. And the directions only want the value of the variable. We would do the same thing for y and get a value of 89. All right, the next theorem says if we have both pairs of opposite angles are congruent, then we have a parallelogram. So if both opposite angles are congruent in both corners, we have a parallelogram. So based on what we know here, we see that we have angles, and these are congruent. And these two angles and these two angles are congruent too. So because of this, this would be congruent. This would be a parallelogram. In this example here, we have opposite sides that are not congruent. This is not a parallelogram. In this example, we have one pair of sides that are parallel, one pair of sides that are congruent. And based on what we talked about a second ago right here, that makes this problem a parallelogram. Okay. All right, here we have diagonals, and we see that this diagonal is not equal to this, and so it is not bisected. This is not a parallelogram. So that gives you a quick overview of the different properties of parallelograms and some examples that go with it.